Okay, we'll look at Chapter 10, which deals with data analysis and an introduction to data analysis. All right, now in Section 10-2, we're going to be looking at Part 1 of displaying data. And we'll talk about two types of data, which is categorical and numerical. Also, we'll look at pictographs, dot plots, stem and leaf plots, back-to-back stem and leaf plots, grouped frequency tables, histogram and bar graphs, and other bar graphs. And I'll touch briefly on circle graphs, which are another way of saying pie charts. Okay. Data analysis usually refers to a more informal approach to statistics. It is a relatively new term in mathematics. So pretty much they use this term to say that we can analyze any type of data by using things like the mean, median, and mode, also the variance and the standard deviation, which we will later talk about in this particular chapter 10. Okay. In statistics, it once referred to numerical information about the state or political territories, and it comes from the Latin statisticus, meaning of the state. And today, much of the statistics involve making sense of data. Okay, so here we're going to be using numerical information to analyze data. And usually graphs are used to try to tell a story, as in this particular illustration here. Okay. A fundamental ideal in pre-kindergarten through grade 2 is that data can be organized and ordered, and that this picture of the data provides information about the phenomenon or question. In grades 3 through 5, students should develop skills in representing their data, often using bar graphs, tables, or line plots. And also, students in grades 6 through 8 should begin to compare the effectiveness of various types of displays in organizing the data for further analysis or in presenting data clearly to an audience. Okay, let's talk about what data is. Data are observations such as measurements, genders, or survey responses that have been collected. Statisticians often collect data from small portions of a large group in order to determine information about the group. This information is then used to make conjectures about the entire group. And describing data frequently involves reading information from graphical displays, tables, lists, and so on. Now, there are two types of data. One of them is categorical and the other one is numerical. Categorical data are data that represent characteristics of objects or individuals in groups, which is, of course, can be thought of as categories such as black or white, inside or outside, male or female. Those are instances of categorical data because you're placing things in categories. Like a person's hair color would be categorical data. Numerical data are data collected on numerical values. For example, in grade school, students may ask whether there is a difference in the distance that girls and boys can jump. The distance jumped is a numerical variable, and the collected data would be numerical. So the distance that a girl or a boy can jump would be considered numerical data. One way of illustrating data is the use of a pictograph. A pictograph is used to represent tallies of categories. For example, categorical data might be seen in determining the month that the most automobiles were sold. The month is the category. A symbol or icon is used to represent a quantity of items. Okay. And here's an example of what a pictograph looks like. Here we see a pictograph of recycled newspapers, and here they use these wrapped newspapers as icons to represent the weight of newspapers. Now, in a pictograph, a symbol or an icon is used to represent a quantity of items. A legend tells what that symbol represents. So here, it says that each of the icons for the wrapped newspaper represents 10 kilograms. And here you have the weight of newspapers here and the months on the left-hand side. Okay, so here you can read off. You can find out how many newspapers there are for the month of December, for example, by counting how many of these icons of wrapped newspapers there are. There are 3 of them. Each one represents 10, so in December there were 30 recycled newspapers, or 30 kilograms of recycled newspapers, I should say. In pictographs, all graphs need titles, and if needed, legends should be shown. Okay, so here's an example of another pictograph. The number of students in each teacher's 5th grade class at Hillview is depicted in tabular representation in the table and in a pictograph. So here, it's pretty much the left-hand side is just a table of each teacher and the frequency or the count. Okay, and each representation of a student represents 5 students. So to represent 20 students in Ames' class, you will need 4 of these icons of a student. And for 25 students in Day's class, you'll need 5 of these icons because each one represents 5 students in that class. All right, next is a dot plot. A dot plot, or another name for that, would be a line plot. It provides a quick and simple way of organizing numerical data. They are typically used when there is only one group of data with fewer than 50 values. Like in this example here, suppose 30 students in Abel's class received the following test scores. And this is a list of all the test scores of those 30 students. And we want to construct a dot plot from this set of data. Okay, a dot plot for the class scores consists of a horizontal number line on which each score is denoted by a dot or an X above the corresponding number line value. The number of X's above each score indicates how many times each score occurred. So this is the illustration of that dot plot. Now here, X's are being used. Okay. So in this case here, if we have a student that scored a 70, so that means we place an X above the 70. Okay. And as you can see, the number of X's to tell you how many times each score occurred. So in this case here, for the score of 82, 4 X's are above that. That means that 4 students got a score of 82 on the test. And usually a dot plot can help you determine the most common score for that particular class in this case. Okay, and like I said here, pretty much it's just a continuation here. Here, 2 students scored a 72, 4 students scored an 82, and there is a gap between the scores of 88 and 97. So you can see there are no X's in between those numbers for between 88 and 97. So there's a gap. Okay, now the score of 52, which you see way out here from all the others, that's called an outlier. Okay, usually an outlier is going to be a data value that is far away from the other data values in that particular set. And then if you got scores that are next to each other, like 97 and 98, they form a cluster. Okay, and keep in mind that's only one example of a cluster. There are other types of clusters that you see here, like between from 80 to 86, I believe. That's also a cluster because you have most of the data values in that particular that are close to each other. And in dot plots, you have an outlier, which is a data point whose values is significantly greater than or less than the other values. So where we had the score 52, that's an example of an outlier, because that's far away from these other data values. A cluster is an isolated group of points. Okay, so we talked about 97 and 98. That's a cluster that forms a cluster. Here we also have another form of a cluster from 88 to 86. And then the gap is the large space between the data points. In this case here, between 88 and 97, that's a gap between those because there are no data values between those two numbers, 88 and 97. And also the mode is the data value or the data values that occur the most often. So if you were to look at this, the mode would be 82 because that occurs the most often. 4 students scored 82. So that would be considered a mode. If a dot plot is constructed on grid paper, then shading in the squares with X's and adding a vertical axis depicting the scale allows the formation of a bar graph. Okay, so with this dot plot, we can put this on grid paper, add a vertical axis like this right here, which we can call the frequency, and that will allow us to form what we call a bar graph. All right, next is a stem and leaf plot. A stem and leaf plot is similar to the dot plot, but the number line is usually vertical and the digits are used rather than the X's. So for the scores in Abel's class that we talked about earlier, we can take those 30 data values and construct a stem and leaf plot. The number on the left-hand side of this vertical bar are called the stems. Okay, so where you see 5, 6, 7, 8, and 9, that's your stem. And these individual number series that you see on the right side, those are called your leaves. There's the stems on the left side, the leaves on the right side. And those data values are 2 digits in this case. So the first number in that data value is your stem. The second digit will be your leaf. And this one is put in numerical order from least to greatest. So here you can see what that data value, what that stem and leaf plot looks like. Most of the data values are in the 80s, as you can see. And with the stem and leaf plot, you do have a legend that says 9 with a bar and then the 7. That represents the number 97. So 5 with a bar and then 2 will represent 52. 7 with a 0 represents 70. 8 with a 0 represents 80, and so on. In an order stem and leaf plot, the data are in order from least to greatest on a given row. And here's some advantages of a stem and leaf plot. They're easily created by hand. They do not become unmanageable when volume of data is large and no data value is lost. But the disadvantage is that we lose the information. In other words, we may know a data value does exist, but we cannot tell which one it is. And how to construct a stem and leaf plot? We first find the high and the low values of the data. And then number 2, we decide on the stems. based on those high and low values. Then number 3, list the stems in a column from least to greatest, and then use each piece of the data to create leaves to the right of the stems on the appropriate rows. Then number 5, if a plot is to be ordered, list the leaves in order from least to greatest. Then number 6, add a legend identifying the values represented by the stems and leaves. And then number 7, add a title explaining what the graph is about. Okay. Now next we have a back-to-back stem and leaf plot. Back-to-back stem and leaf plots can be used to compare two sets of related data. In this plot there is one stem and two sets of leaves, one to the left and one to the right of the stem. So in this case, the stems are going to be in the middle. The left will be your leaves from one class. The right will be leaves of the other class, like in this case, second period and fifth period class of Mr. Abel's test scores. Okay, and as you can see, there is a title, and for the left and the right side, you do have a legend, like 0 slash. Now the 5 is in the middle of the 2 bars, and then the 0 is on the left side. That represents 50. Notice that the 5 is in the middle. Now the 2 is on the right side. That represents a score of 52. Let's look at this example. Group the presidents into 2 groups, from George Washington to Rutherford B. Hayes, and from James Garfield to Ronald Reagan. All right, this table represents the president and the age of their death. Now next we're going to create the back-to-back stem and leaf plot of the 2 groups and see if there appears to be a difference in ages at death between the 2 groups, and which group of presidents seem to have lived longer. Now here's what that back-to-back stem and leaf plot looks like. Here the ages of death vary from 46 to 93. So we can use stems that vary from 4 to 9. So we start with 4, and then 5, 6, 7, 8, and 9. Now the first 19 presidents are listed on the left, and the remaining 19 on the right. So the early presidents on the left-hand side. The later presidents on the right-hand side. And those leaves are listed in order from least to greatest on this side. Now on the left side, the leaves are listed from least to greatest, starting from the right to left. Or you can say from greatest to least if you want to. And of course those legends are given there in that particular problem. So here you can see how a back-to-back stem and leaf plot is created. The early presidents seem on average to have lived longer because the ages at the high end, especially in the 70s through the 90s, come more often from the early presidents. The ages at the lower end come more often from the later presidents. And then from the stems, in the 50s and 60s, the number of leaves are about equal. Okay. A stem and leaf plot shows how a wide range of values the data cover, where the values are concentrated, whether the data have any symmetry, where gaps in the data are, and whether any data points are decidedly different from the rest of the data. So if I want to go back to I can go back to the back-to-back stem and leaf plot. You can find out, usually, you can find out with the early presidents there might be some type of symmetry here on the left side, and also you might see a little bit of symmetry here on the right side for the later presidents. Okay, next is frequency tables. A grouped frequency table shows how many times data occurs in a range. Here, the data for the ages of the presidents at death are summarized in the table. Okay, so as you can see here, we can use that frequency table. Now, the ages of death, notice that the range is from 40 to 49, then 50 to 59, 60 to 69, and so on. And then they tallied how many of those deaths were between 40 and 49. There were only 2. And from 60 to 69, for example, there were 12. 70 to 79, there were 10. Some characteristics of frequency tables are that each class interval has the same size. And the size of each interval can be computed by subtracting the lower endpoint from the higher and adding 1. Like, for example, from 49 to 40, 49 minus 40, plus the 1 will give you 10. So the size of that interval is going to be 10. And of course, we know how many data values occur within a particular interval, but we do not know the particular data values themselves. Okay, so in this case here, with that frequency table, we know that there are 12 presidents that died between 60 and 69. There were 12 presidents who died, but we don't know actually who those 12 presidents that died and what age between 60 and 69 that they died. Okay. Some more characteristics of frequency tables are, as the interval size increases, information is lost. And also, the classes should not overlap. That means 40 to 49. Then the next one must be 50 to 59. There is no overlap in between. So you can't say 40 to 50 and then the next one be 50 to 60. Here there's an overlap with the 50. Because if you have somebody that died at age 50, then you don't know whether it goes in this class interval or in this class interval. So there should not be any type of overlap. It should be 40 to 49 and then 50 to 59. Okay, a histogram is made up of adjoining rectangles or bars, and the bars are all the same width. The scale on the vertical axis must be uniform. Okay, so this is histograms and bar graphs. Like the death ages are shown on the horizontal axis, and the numbers along the vertical axis give the scale of the frequency. So the frequency is this vertical axis here. The horizontal axis is going to be the ages in years. Those intervals are given to you: 40 to 49, 50 to 59, 60 to 69, and so on. And here's what the bars look like. There are 2 that died between 40 and 49 that died. 50 to 59 is this bar. 60 to 69 is this bar, and this continues. Now the frequencies are shown by the heights of the vertical bars each having the same width. So to show that 12 presidents died between the ages of 60 and 69, that would be this bar up here going up to 12. And of course, your bar graph would have a title. Well, histogram should have a title as well. And your vertical and your horizontal axis has to be labeled. And of course, the frequency, the vertical scale has to be uniform. Now, a bar graph is like a histogram, but it's a little bit different because it typically has spaces between the bars and is used to depict categorical data. So in this case here, these are the bars that represent Tom, Dick, Mary, Joy, and Jane. And they can be placed in any order. In this case, this deals with the heights of those 5 students. Here you have your vertical axis here for the height in centimeters. And these are the students: Tom, Dick, Mary, Joy, and Jane. And you can see that those bars are separated from each other. So here bar graphs are basically used when you're dealing with categorical data. Okay, a distinguishing feature between histograms and bar graphs is that there is no ordering that has to be done among the bars of the bar graph, whereas there is an order for a histogram. So with a histogram, we had to do 40 to 49, 50 to 59, 60 to 69, and so on. But with that bar graph of those 5 students' heights, the order does not matter. And a double bar graph can be used to make comparisons in data. So here, with the later presidents and the earlier presidents, here you can use different colors to represent the different presidents, the later president and the earlier presidents, as you can see here. And other bar graphs are, the table shows various types of students, various types of shoes worn by students in one class, and the appropriate percentages of students who wore them. Okay, so here we have the dress, flip-flops, Crocs, loafers, and tennis, their frequency, and their percentage. Okay, and note that the percentages are approximate to a sum of 100%. And this figure represents the percentage bar graph of that same data. Okay. But this is what that bar graph looks like now. In class, we won't be discussing this particular type of bar graph in the homework, but pretty much you can see how that looks, well, percentage bar graph looks like. Okay. The table shows information about the expenditures of a business over a period of years. As you can see, the materials and labor with those amounts given for those decades from 70 to 79, 80 to 89, 1990 to 99, and so on. And this represents a stacked bar graph with that same data. Notice on the left-hand side, the percentages is all the way up from 0 to 100%. And then the decades are given on the horizontal axis. The bars are in different colors, where the lighter bar is the labels, the materials are the darker ones are labeled, the lighter part of the bars are materials. So here, they're stacked in a way so that the sum of these two have to equal to 100% on each of those individual bars. Okay, now I'll briefly talk about circle graphs or pie charts. A circle graph or a pie chart is used to represent categorical data. It consists of a circular region that's partitioned into disjoint sections, with each section representing a part or percentage of the whole. And a circle graph shows how parts are related to the whole. Like in this case here, if we want to construct a circle graph for the information in the table, which is based on survival and death rates of the crew and passengers in the various ticket classes on the Titanic. You want to construct a circle graph for the survival group and the death group by make comparisons. So this is what the table looks like for the number in the class that survived and the number in the class that died on the Titanic. Okay, now I'm going to skip over to this slide so that you can see what the graph looks like. Okay, now this may be hard to see, but if I had this in color, you can see here that you have your crew here, which is 30%, the first, which is 28%, the second, which is 17%, and the third, which is 25%. And you can see first, second, third, and then the crew for survival. And then the next one is for deaths, those who died. The first was 47%. You can see that particular piece of the circle. This small piece represents second. This one represents third, and this one is the crew, which is 26%. Now, we won't do circle graphs in class because we do have technology that can help you create circle graphs. Like Microsoft Excel is a good software that helps you create circle graphs in this case. All right, so that will conclude this particular video on the first part of displaying data.